Okay. Today I want to talk about section 3.7, optimization problems. This is outline. I'm going to give you like some motivation so I can let you know how we can solve optimization problems. Solved one, I will give more examples. The first one, a business person wants to minimize cost and maximize profit, that we call optimization problem. A traveler wants to minimize transportation time. This is optimization problem. In this section, we solve such problems as maximize area, volumes, profit, and minimizing distance, times, and costs, like this, all optimization problems. So we have some steps in solving optimization problems. Step 1, understand problem. Second one, draw a diagram. Third one, introduce notation. Like Q, the quantity that is to be maximized or minimized, usually don't use Q. So depending on the minimize distance, you can use D. The maximize cost, like C, right? The minimize cost, C, like maximize volume, V. The maximize area, A. The depending on your choice of notation. Just in the only one case, you have to give a notation of quantity that is to be maximized or minimized. A, B, C, and X, Y, and so on, the other kind of things, you can use other unknown quantities. Step 4, express Q in terms of some of the other symbols from step 3. Step 5, express Q as a function of one variable, X, say Q equals f of X, only one variable. Next, find the domain. Step 6, find the absolute maximum or absolute minimum of f from the problem. Problem require that you have to find absolute maximum. Yes, you can find absolute maximum. Your problem require that you have to find absolute minimum. Yes, you can find absolute minimum. By using the closed interval method, the first derivative test or second derivative test. We have the 3 kinds of methods. So here, what's a closed interval method? We use this one to find the absolute maximum and minimum values of a continuous function f on a closed interval AB here. So we have 2 conditions for using closed interval method. What's that? The function f is continuous. The interval is closed interval. The one example. The domain is open interval. Don't use closed interval method. The function f is discontinuous. Don't use closed interval method. Just continuous function and domain is the closed interval. We can use closed interval method. We follow 3 steps. Step 1, find the values of f at the critical numbers of f in open interval AB. Step 2, find the values of f at the end points of interval. What's end point? A and B. So what does it mean? You have to find function value at A and function value at B. You can find 2 function values like this. Step 3, from step 1 and step 2, you can choose the largest of the values from step 1 and step 2 is the absolute maximum value. The smallest of these values from step 1 and step 2 is the absolute minimum value. So this is like idea for finding absolute maximum, absolute minimum. Was it like a first derivative test? The first derivative test. Suppose that C is a critical number of a continuous function f. So if f prime changed from positive to negative at C, the f has a local maximum at C. If f prime changes from this like typo here, sorry, the changes from negative to positive at C, f has a local minimum at C. F prime is positive to the left and right of C, or negative to the left or right of C, then f has low local maximum, no local minimum. So I'm gonna write again. So what's that? Was it like a critical number? What's that? This is definition is the next one, either f prime of C equal to 0 or f prime of C does not exist. This one. But one more. This is like first condition. The second condition is C is in the domain. So like a critical number, you can check. The first case, you can draw real line, the domain, and plus C, you can check f prime of x. The x value is like less than C, so we have positive, the greater than C, we have negative. What does it mean? Function f of x is increasing, decreasing. So what does it mean? The f of C is the local maximum, right? This is local maximum. The second case, similar. F prime of x, the left-hand side, negative. Right-hand side, positive. What's it like f of x? F of x is decreasing, increasing. So what's it like f of C? F of C is local minimum. Third one is like C, f prime of x, positive to positive, or negative to negative. So what's that? F of C is not local maximum, not a local maximum, not a local maximum, but not a local minimum. But not a local maximum, not a local minimum. Okay, this is like a first derivative test. What's the second derivative test? Suppose second derivative continuous at C. F prime of C equal to 0, second derivative is greater than 0, we have local minimum at C. F prime of C equal to 0, second derivative is less than 0, F has local maximum at C. This is true? Yeah, this is true. You can check some graph. Graph is like this. This is C. What happens? F prime of C is equal to 0. We have a horizontal tangent line. So what's that? The graph is concave down. What does it mean, the concave down? So second derivative is here, sorry. F prime C equal to 0. Second derivative is less than 0. So what does it mean? We have local maximum here. Local maximum at C. Graph is like this. C. So we can draw horizontal tangent line at C. What does it mean? F prime of C equal to 0. The graph is concave up. What is concave up? Like second derivative is greater than 0. So we have local minimum at C. We have local minimum at C. Local minimum at C. Okay, this is like a second derivative test. Here, this is like examples. So a farmer has the 2,400 feet of a fencing and wants to fence off a rectangular field that borders a stray river. He needs no fence along the river. What are the dimensions of the field that has the largest area? So how can you do that? The step one, you just on understanding problem. Was it like step 2 and the step 3? The step 2 and step 3. Step 2, draw diagram. Step 3, we need notation. So what's that? Here, we have strain lever. The strain lever here. You have to fence. So what kind of fence? You don't need a fence along the river, only 3 sides, rectangular fence, right here, rectangular field, you can do fence off. So we have this river. You don't need any fence. You don't need any fence in here, only need this one, this one, this one, is right? X, X, Y, you don't need this portion. It's like exactly diagram, so like this. So we need notation. What is X? The depth of a rectangle. The Y, the width of a rectangle. A, the area of a rectangle. We need this kind of things. So step 4. Why need this A? Because here you can find largest area. What is like a largest area? You have to maximize the area. The area is like the one quantity that is to be maximized. We need A. So how can you find A? We need the depth and the width. We need X and the Y. This is like reason. You can use 3 notations. So step 4. What is step 4? You can find equation. How can you find area A? Exactly X times Y. So like this. Step 5 is you have to express A in terms of only one variable. Is right? Only one variable. You can express A as a function of one variable. Only one variable. So you can choose. How can you find the one variable? You need to find the relation of X and Y. The relation of X and Y. How can you find the relation of X and Y? You can use given information. What's a given number? We have one given number, 2,400 feet of fencing. So what's that? Exactly. X plus Y plus X is 2,400. This is 2x plus y equals 2,400. So you can subtract 2x from both sides. Y equals 2,400 minus 2x. We can plug this one into here. So we have area A. What's that? X times 2,400 minus 2x. You can distribute x. What's that? The 2,400x minus 2x squared. That's right. So we have it. This one. We can use only one variable x. The next, find the domain. So what's like y? This y is we have here. X was like a domain. So from the like diagram was like x. X is depth of a rectangle. The depth of a rectangle is only positive number. This is a one restriction. Like a domain. One more, y is also positive y equal to 0. You solve. You add 2x to the both sides. So we have 2x. So we have 2x is less than y equal to 2,400. Divided by 2, so we have x is less than y equal to 1,200. We can combine. X is greater than y equal to 0 and less than y equal to 1,200. What's like a domain? Domain is from 0 to 1,200. This is like a domain. We have a domain. So, what's like a main problem? What's the main problem? maximize area, find absolute maximum of A. How can you find the absolute maximum of A? So we have 2 or 3 methods possible, like closed interval method, the first derivative test, or second derivative test. So you can choose 1 out of 3 methods. It doesn't matter. I can choose a closed interval method because the AX is continuous function. What's the domain? Domain is closed interval. The closed interval, I want to use the closed interval method. What is like a closed interval method? Here. This one is right. Here, function f is continuous, interval is closed interval. I will follow 3 steps. Like this. So I can do that here. This one. So we have it. Step 6. Use the closed interval method. So what's that? Find the, we have to sum the step A, step B, step C. Find the value of A at the critical number. How can you find the critical number? Here. Was it like A of X? The A of X is given. A of X is, so we have, what's that? Here, yeah. X times 2400 minus 2X. Expanded form is 2400X negative 2X squared is A of X. X is between 0 and 1200. Find the critical number. What's that? A prime of X equal to 0 or A prime of X does not exist. A prime of X. How can you find A prime of X? You can calculate here. A prime of X is only this one prime. So we have this one negative 4X. So A prime of X equal to 0. So exactly. So this one equal to 0. 2400 negative 4X equal to 0. A prime of X does not exist. So A prime of X is a polynomial, always well defined, but we don't have it. This kind of things you solve. Add 4X to the both sides. So 4X is 2400 divided by 4. X is 600. So 600. 600 is in the domain. In the domain. So you can calculate A of 600. Right? Like this. A of 600 is plug 600 into this one. So 600 times 2400 minus 2 times 600. We have 600 times so 2400 minus 1200 is only 1200. So 12 times 6 is 72. We have 4 zeros. We have it. The 720,000. 720,000 is like A of 600. B, you have to find function values at endpoints. You can calculate A of 0, A of 1200. You can calculate A of endpoints, so 0 and 1200. You plug 0 into factor form is better. Plug 0 into here. So we have 0 times minus 2 times 0. The 0 times 2400 is 0. You can plug 1200 into factor form X again here. We have 1200, 2400 minus 2 times 1200. 2400 minus 2400 is 0. 0 times 1200 is 0. We have three numbers, 720,000, 0, the 0. We have these numbers. What's it like C? So what's it like a main problem? Maximize area. Is right? Maximize area. So what's that? The absolute maximum is of area is this one. At x is 600. Is right? So like this. So what's it like a question? The question is, what are the dimensions? Find what? X and Y. How can you find the Y? The X is what? 600. So we have it. How can you find the Y? We can use this relation. You plug 600 into here. Here we can calculate the 2400 minus 2 times 600. It's like a Y value. Exactly Y value. Here you can plug this one into the Y. Y equals, what's like Y? Yeah. So 2400 minus 2 times X. So 2400 minus 2 times 600. 2 times 600 is 1200. So 2400 minus 1200 is 1200. So what's like dimensions? So this is the final answer. What's like dimensions? So what's like a unit? The unit is feet. This is feet. So we have dimension is, what's like dimensions? 600 feet times 1200 feet. So that's it. It's like a whole idea for solving this problem. We can find dimensions. It's good. This is the whole idea for solving the first example. This is like all procedure. Like this. Right? Like this. The next thing. A cylindrical can is to be made to hold the 1000 cubic centimeters of oil. Find the dimensions that will minimize the cost of metal to manufacture the can, right? So we have step 3, what's that? Cylindrical can. What is like a cylindrical can? We have like this. The cylindrical can. So we have radius R, height H. We have these kind of things. Now let me see. You have to minimize the cost of metal. How can you minimize the cost of metal? To automatically minimize the surface area. Just only what? To minimize the surface area. Minimize the surface area. A, automatically we can minimize the cost of metal, is right? So minimize the surface area A. How can you find the surface area? You have to unfold this one. Unfold. So what happens? So we have side has like a rectangle. Side has rectangle. The top one is like a circle. Bottom one is also circle. Unfold this one. This radius is R. Height is H. So how can you find this one? This length of rectangle is exactly same to circumference. The circumference. So this one is the 2 pi r, right? 2 pi r. So what is area A? So you can define equation area of A. The step 4. Area A is the 2 circles. One circle pi r square. Second circle pi r square. Plus area of rectangle. Area of rectangle is the width times length. Length is 2 pi r times h. So we have 2 pi r h. So we have a equals the pi r squared plus the pi r squared is 2 pi r squared plus 2 pi r h. This one. What is like step 5? Step 5, you need to express area A of a function of one variable. So far, we have two variables, R and H. So how can you find? You need to find the relation. You can find the relation of R and H. What's like the relation of R and H? You have to use given number. Given number is exact volume of cylindrical can. What's the volume of cylindrical can? Remember, this is the volume of a cylindrical can is the pi r square, the area of base, times height h, pi r square h. Volume is 1,000. You plug 1,000 into here, so we have the pi r square h equals 1,000. The next, I'm going to solve this equation for h is better. If you solve this equation for r is the square root or something like that. The square root is not good. So I can use a simple case. So only divided by pi r square. Pi r square is crossed out. H is the 1,000 over pi r square. You can plug this h value into here. So what's that? The a is 2 pi r square plus 2 pi r times h is 1,000 over pi r square. The 1 pi is crossed out. The 1 r is crossed out. So we have the 2 pi r square plus 2 times 1,000 is 2,000 over r, right? This is a over r. Was it like domain? Here, was r? The r is radius, or is what? Positive number. That's it. This is domain. We have this one. So what's the next step? You have to what? Minimize. So what does it mean? Absolute minimum of AR. So R is not a closed interval. Domain is not a closed interval. I cannot use. So we cannot use closed interval method. We have to use the first derivative test or second derivative test. I'm going to use first derivative test for finding absolute minimum of A of R. So this is the whole idea. So you can just keep. So this is my explanation, exactly the same. So like this, plug. So we have this one, domain this one, like this. Step 6, to use the first derivative test for finding absolute minimum of AR. So how can you find? So you can use like a critical number. So you can calculate a prime of R. So exactly the 2 pi r square, this one is right, the 2 pi r square plus 2,000 of r prime, what's that? The 2 pi is constant, you have to keep. The r square prime is 2r plus, what is 2,000 of r prime here? 2,000 over r prime is the 2,000 prime times r plus. Sorry, double plus. Negative, really be careful. You have wrong answer by using positive. So you write here. So negative 2,000 times r prime over r square. So what happens? 2,000 prime is 0. You don't need it. R prime is just 1. So we have negative 2,000 over r square. So you can change. It's not positive, change negative. Negative 2000 over r squared. So what's that? It's the same to 4 pi r minus 2000 over r squared. I will change this difference to only one fraction with a common denominator. This is has like the 1. So what's that? You just only multiply top and bottom by only r squared. Like this. So what's that? So this is same to the 4 pi r squared is 4 pi r cubed negative 2000 over r squared. So you can solve. So a prime of r equal to 0 or a prime of r does not exist. A prime of r equal to 0 exactly numerator equal to 0. So we have 4 pi r cubed minus 2000 equal to 0. So add 2000 divided by 4 pi. The r cubed is 2000 over 4 pi. 4 is crossed out. We have 500 over pi. You can take a cube root, was like r. The r is the cube root of the 500 over pi. So we have, this is r. So a prime of r does not exist. Only denominator r squared equal to 0. Denominator r squared equal to 0. So we have r equal to 0. But this is not a critical number because what's the domain? What's the domain? Domain is here always the greater than 0. We don't have it. That is not equal to 0. So we have only one critical number, cube root of 500 pi. The next, you can check. So we have a absolute minimum at cube root of 500 pi or not. How can you know that? You can draw domain from 0 to infinity. You plot the cube root of 500 pi. So you can check. A prime of r is positive or negative. I can choose one number on the left-hand side. Choose one. You plug 1 into here. 4 pi times 1 cube negative 2000 is negative number. 1 square is a positive number, like negative. You can choose this number is greater than cube root of 500 pi. I can choose a really big number, the 1000. The 1000, you plug 1000 into r. The 1000 cube times 4 times pi is really big. The bigger number minus 2000 is like a positive number, real positive. The 1000 square is also positive. Positive or positive is positive. That's right. You can plug 1000 with positive. What is a of r? Graph is decreasing, increasing. What happens? We have only one critical number. Graph is just what? Decreasing and increasing. Only decreasing and increasing. So this value is local minimum. The local minimum is exactly the same to absolute minimum. That's it. This is the idea. So we have the here absolute minimum at here. The absolute minimum at x, this r, sorry, r. So r equals cube root of 500 over pi. Is right? What's the question? So you have to find dimensions of cylinder. What's the dimensions of a cylinder? You can find radius r, height h here. What's dimensions? You need to find here. We have r. What's r? The cube root of 500 over pi. You can define h. How can you find the h? You plug this value into here. right? You can plug the 1000 over pi r squared and calculate. What's that? The h is the 1000 over pi, the cube root of 500 over pi square. You can change this one to the 1000 over. What's the cube root of 500 of pi? Exactly 500 of pi to the power 1/3 and square. The 1/3 times 2 is 2/3. We have 500 pi over 2/3. You have to distribute 2/3 to the numerator and the denominator. So we have pi times 500 2/3 over pi to the 2/3. Is right? So like this. So what's the next one? You can just simplify this one. You can keep 1000 over, keep 500 2/3, keep pi over pi 2/3. What's it like a pi over pi to the 2/3? Pi is like power 1, exactly pi to the 1 minus 2/3. So we have pi to the 1/3. We have here pi to the 1/3. So one more. Was it like a 1000? The 1000 is like a 500 times 2. This is what? The 1000 is exactly same to change it like this. 2 times 500. The 500 times power 1, so you can keep 2, you keep pi to the 1/3. What's that? You can combine 500 to the power 1 over 500 to the 2/3 here. So 500 power 1 minus 500 power 2/3. This is 500 power 1 minus 2/3 is 500 to the power 1/3. So we have it. So 500 times 500 1/3. You can combine 500 and pi. Combine with same exponent, 2 times 500 of pi to the 1/3. You can change it back to cube root. 2 times the cube root of 500 of pi. What's the cube root of 500 pi? Exactly same to r. So we have this one, this relation. So how can you minimize cost of metal or manufacture the can? So hide is always the twice of the radius. We have this result, is right? This is like a whole idea for solving this problem. What's it like dimensions here? The dimensions of this one is radius is cube root of 500 pi. What's it like a unit? You can use centimeter. What's it like h? H is this calculation here. We have 2 times cube root of 500 of pi centimeters. So that's it. This is exactly the answer of the second question. This is the whole idea. So you can find all summarized in here. The same to my explanation, like this. And calculate. So we have it like this. Right? Thus, to minimize the cost of the can, the radius should be the cube root of 500 over pi centimeters, and the height should be equal to twice the radius, right? Twice the radius. It's like a whole idea. The next example, find the point on the parabola y squared equal to 2x. So let me see. You can draw diagram first. How can you draw the diagram? So you have to know this kind of things. Remember that we have the y equals like ax squared. We have two possible graphs. First one, a is positive, graph is open up. The next one, parabola. The second case, the a is less than 0. What's graph? The graph is open down. The passing through the origin, open down. Open down, so like this. We have two possibilities. One more. So what is it like x equals? What's x equals a y squared? We have two possibilities. The a is positive number, always open to the right. We have open to the right, like this. Second one, a is less than 0, always open to the left. Graph is here, open to the left. Open to the left, like this. But here, what's that? It's the same to x equals 1 over 2y squared. The 1 over 2 is a. 1 over 2 is a. A is positive here. Open to the right. Open to the right. So we have it. Graph is so like this. Open to the right. You choose 1, 4. So what's it like main problem? You have to choose x, y on the curve. Y squared equals to 2x. The given point 1, 4, 1, 4. This is like a typo here, 1, 4. So not 1.4. The 1 and 4 is like a given point, 1 and 4. This one. So find the point on the parabola that is close to the point. What does it mean? What's like this exact meaning? Just to minimize. Distance between 1, 4 and xy. 1, 4 and xy. Like this. So what does it mean? You can choose this one, point here, this one, point here, this one. Which length is smallest one? Which length is smallest one? Then minimize the distance. So what's like D? So D is like this one. So we have step 4. What's D? The square root of, remember distance formula? The square root of x minus 1 square plus y minus 4 square. Like a distance formula is right. X minus 1 square plus y minus 4 square, take a square root, like a distance. But one more, the distance is always a positive number, so this is always equivalent. The minimize t equivalent to minimize d squared. It doesn't matter. Minimize d squared. We have same point. It doesn't matter. The minimize d squared. We have same point. The distance is like the different, but the point is like doesn't change. The point doesn't change. So minimize d squared. What's that? The minimize the d squared. So we have d squared is only the square root of x minus 1 square plus y minus 4 square and squared, the d square. So we have x minus 1 square plus y minus 4 square. So why do you like square d? Because how can you find the absolute minimum and absolute maximum? I want to use the first derivative test or closed interval method or second derivative test. You need the first derivative. You can take a derivative with square root form, the very complicated. So d squared doesn't have a square root, like d square prime is very simple. The calculation is very simple. This is like a reason. So one more. The step 4, step 5 is, on step 5, you just only change the d square as a function of one variable. You can find the relation of x and y. What's it like a relation of x and y? The relation of x and y. X and y is here, given. Y square equals 2x. So y square equals 2x is given. So only divided by 2, x equals 1 over 2y square. You can plug into here. What's that? So we have the 1 over 2. This like d square is 1 over 2y square minus 1 squared plus y minus 4 square. This is like the function of y, like g of y, like this. What's the domain? Domain is the corresponding y value. You can choose points here. The corresponding y value is this one. To this point, 0. To this point, this one. What does it mean? The all real numbers. So this is what's like y from negative infinity to infinity. The all real numbers. Like a domain, right? It's like step 5. So here, like this. We can write, can use f, not g, the f of y, like this. The next tip, the two minimize of d occurs at the same point as a minimum of d square, but d square is easier to work with it. I already explained this kind of things, right? So next tip, what's like next step? The find absolute minimum, right? The absolute minimum. You can minimize the distance, the absolute minimum of f of y. You can find absolute minimum of f of y. What's that prime y? Here, f of y is 1 over 2y square minus 1 square plus y minus 4 square prime. You can use chain rule. So 2 is down. 1 over 2y square minus 1 times 1 over 2y square minus 1 prime minus y minus 4 square prime is, use chain rule again, 2 times y minus 4 times y minus 4 prime. You can distribute 2. 2. So we have y square minus 2 times the 1 over 2y square minus 1 prime is only the 1 over 2 times 2y, y 2 is crossed out, just y. So here, y minus 4 prime is just 1, you don't need it. Only distribute negative 2, we have negative, this is positive, why change it positive, sorry, this is like a typo, so it doesn't change it, it's positive, sorry, positive, distribute 2, so 2y negative a. You simplify, distribute y cubed negative 2y plus 2y minus a. So we have y cubed negative a. This is y prime of y. So you can find critical number, like critical number, what's that? So f prime of y equal to 0 or f prime of y does not exist. Does not exist. So this one, f prime y equal to 0, exactly y cube minus 8 equal to 0. So we have the y cube minus 8 equal to 0. You solve y cube equal to 8. Take cube root y equals to 2. Y prime of y does not exist. The y cube minus 8 is always well defined, though we don't have it. No, we don't have it. So only one critical number, y equals to 2. The next, you have to plug to here. So we have f prime of y is positive or negative. I'm going to choose test number 1. You plug 1 into here. The 1 cube negative 8 is negative 7. I'm going to choose 3. plug 3 into y. 3 cube minus 8 is 27 minus 8 is 19 is a positive number. So what's like f of y? The f of y is decreasing and increasing. So we have only one critical number. Graph is decreasing and increasing. So what does it mean? The local minimum is exactly absolute minimum. The absolute minimum. So we have absolute minimum at 2. At y equals to 2. Y equals to 2. What's like a problem? Problem is find the point. Point has x component, y component. Y component is here, right? Y equals to 2, so we have it. You plug y equals to 2 into here. You can find x value. How can you find the x value? You can use relation of x and y here. X equals 1 over 2. Y is 2, 2 square. The 2 is crossed out, only 2. What's the point? The final answer is, the point is the x and y. The x is 2. Y is, we have it here, is right? 2. So that's it. This is your final answer. We can find point x component to 2, y component to 2. It's the whole idea for solving this problem. The all explanation is here, the same. To the my explanation, the same. So like this is a 2, 2, is right? We have this point. Okay, the next example. Next example is find the area of the largest rectangle that can be inscribed in a semicircle of radius r, right? Find the area of the largest rectangle that can be inscribed in a semicircle of radius r. So how can you solve this problem? Same. You can use step 2 and step 3. You can draw a diagram. What's like a diagram? The diagram is, this is like better. You can draw your line. You can use semicircle. This one is semicircle, radius r. Here, the semicircle, radius r, like this. It's a negative r and r. So you can draw large rectangle can be inscribed in semicircle. So we have this one like this. So this point is xy, so like this. So we can find this area is like A. So we have it, right? So like this. So here, so like this. So exactly this length is x plus x is 2x. One more, x is only use a positive number. You can show negative number, always symmetric about y-axis, only use positive x values. This is possible. A is area of rectangle. So what's that? You have to maximize area here. Maximize area. Maximize area A. We have x and y value. What's like A? So A is here, 2x times y. So we have 2xy. What's like step 5? The step 5 is, what's step 5 is? So you just express A of a function of one variable. You have to eliminate x variable, y variable. How can I eliminate the x and the y variable? So you can use the relation of x and y. What's that? You can use equation of a circle, x squared plus y squared equals r squared. Only solve for y squared, subtract x squared from both sides. So y squared equals r squared minus x squared. Only take square root, y is square root of r squared minus x squared or negative square root of r squared minus x squared. So let me see. Was it like y value? Only use upper semicircle. We don't have lower semicircle. The y value is always a positive number, so we don't use it. Only plug this value into here, y. So was it like a is 2x times square root of the r squared minus x squared. This is a of x. What's like a domain here? The domain is 0 to r. What's that? Like this. So we have this idea. Here, like this. So we have a is continuous function. So domain is closed interval. So we can use the closed interval method for finding the absolute maximum of A, area A. So find the values of A at the critical numbers of A in 0R. Was A prime of X? You can take a derivative here. 2x root r squared minus x squared prime. So we can use product rule. So 2x prime square root of r squared minus x squared plus 2x times square root of r squared minus x squared prime. So what's like a 2x prime? The 2x prime is only 2 times square root of r squared minus x squared plus 2x times the square root of r squared minus x squared prime. I can calculate the second part. I can write here. R squared minus x squared to the power 1/2 prime. You can use chain rule. 1/2 is down. Inner function r squared minus x squared to the power 1/2 minus 1 times inner function r squared minus x squared prime. So this is 1/2 times r squared minus x squared to the power minus 1/2 times. So let me see. So really be careful. What's like a variable? The variable is x. The r is fixed number, like a constant. The r squared is constant. Constant prime is 0, not 2r, just 0. R squared prime is 0. The negative x squared prime is negative 2x. We have negative 2x. So what happens? 2 is crossed out like this. You can change it to the positive exponent. R squared minus x squared to the power 1/2 times negative x. So we have negative x over r squared minus x squared to the power 1/2 is square root. So like this. So what's that? Negative x over the square root of r squared minus x squared. That's good. The next tip. I will change it. This is 2 times square root of r squared minus x squared over 1. Here, the 2x times minus x is the negative 2x squared over square root of r squared minus x squared. I will change this one to only one fraction with common denominator. How can you find common denominator? Common denominator is exactly the square root of r squared minus x squared. So you don't need to change the second part, only change the first part. Here, multiply top and bottom by square root of r squared minus x squared, the square root of r squared minus x squared. So what's that? So we have this one. So this is same 2. So you can keep 2. Here, the square root of r square minus x square times square root of r square minus x square. Square root is gone, only 2 times r square minus x square. So next one is negative 2x squared over square root of r square minus x square. Only combine, what's that? This is 2r square minus 2x squared minus 2x squared is 4x squared over square root of r squared minus x squared. So we have it. We have this kind of forms. The next thing, you need to find like the critical number between 0 and all. How can you find the critical number? You can just solve a prime of r equal to 0 or the a prime of r does not exist. A prime of r equal to 0, only the numerator equal to 0, the 2r squared minus 4x squared equal to 0. You add 4x squared, same to the 4x squared equal to 2r squared divided by 4. So this is same to x squared equals divided by 4, 2r squared over 4. 2 is crossed out, r squared over 2. 2. So what's like x here? X is take square root. We have 2 possible answers. The positive r squared over 2 or negative r squared over 2. So what's like x? X is the r over square root of 2 or negative r over square root of 2. What's the domain? 0 to r. What does it mean? So ignore negative. Not in the domain. Not in the domain. Second part, only the bottom one equal to 0. Bottom one is r squared minus x squared equal to 0. The r squared minus x squared equal to 0. So we have x squared equals r squared. The take square root, x is the square is gone, only positive r or negative r, the same. What's like domain? Only open interval 0 and r and the minus r, not in the domain. So what does it mean? We have only one critical number, r over root 2, r over root 2. So this is like step up. So we have it, r over root 2, like this. You can plug r over root 2 into the a of r. What's a of r? So do you know this a of r? A of r is, so we have 2x. So what's that? 2x over square root of r squared minus x squared is exactly ar. You plug r over root 2 into x. So we can calculate. This is 2 times r over root 2 square root of r squared minus r over root 2 squared. Here was it 2. 2 is exactly keep 2 times r over root 2. So here the square root of the r squared minus r over root 2 squared is r squared over 2. So r squared is 2r squared over 2. And subtract 2 times r over root 2 times square root of the r squared over 2. So we have 2 times r over root 2 times, this is r over root 2. So 2 times r times r is r squared. The root 2 times root 2 is only 2. 2 is crossed out, r squared. So we have it like this. Find the value of a at the end point of the interval. What's the end point? 0 and r. You can plug 0 into ar. So here was a. A is what's like a of x? A of x is 2x square root of r square minus x square. The left-hand point is like 0. Plug 0 into here, is right? You check. Was it like left-hand and right-hand point here? Left-hand point is like 0, right-hand point r. Do we have it? Here, you plug 0 into here, 2 times 0. The square root of r square minus 0 square. R square minus 0 square is r square, but 2 times like 0. 0 times r is like 0. So next to a of r. You plug r into x again here. A of r is 2 times r. Square root of r square minus r square. R square minus r square is like only 0. 0 times 2r is 0. We have 0. So what's like numbers? We have a over r over root 2 is r square. A of 0 is like 0. AR is like 0. You have this one. So what's the absolute maximum? Absolute maximum is we have 3 numbers, exact 2 numbers, r square and 0. The r square is like greater than greatest one. So we can find absolute maximum value r square at what is x? X is r over root 2. So like this, at x equals r over root 2. Therefore, the area of largest inscribed rectangle. Largest inscribed rectangle is right. The area of the largest inscribed rectangle is r squared. This is final answer. So that's it. That's the whole idea for solving this problem. Okay, so next one. So we think about the last problem. A rectangular storage container with an open top is to have a volume of 10 cubic meters. The length of each base is twice the width. The material for the base costs $5 per square meter. The material for the size costs $18 per square meter. Find the cost of materials for the cheapest such container. So this is like equation. How can you solve? You can draw rectangle. We have a rectangular storage container. Do we have it? The length is I, width is W, height is H. Do we have this kind of things? So what's that? W is width, L is length. So what happens? We have one thing. The length of each base is twice the width. We have L equals to 2W. H is height. The C is cost of material. The Y here. What's that? Find the cost of material for the cheapest such container. What does it mean? Minimize cost. Minimize the cost. So cost function is C. What's it like step 3? Step 4? You can find cost function. How can you find the cost function? Here, the first one. What's it like area base? The area base is this one. Exactly L times W. We have L. What's L? 2W. So we have the area of the base 2W times W is 2W squared. That's right. The next tip. What's the area of size? Here we have this one. The left-hand side, right-hand side. What's that? H times W. We have WH. So we have, two sides, the left-hand side, the right-hand side, W times H. WH plus WH. Next, front. The front is, what's the front? This front is exactly 2W times H. We have 2WH. What's like a bag? It's a bag. Bag is, the area of bag is exactly same to area of front, 2WH. You can add it. WH plus 2WH plus 2WH is 6WH. We have these areas. Next, the don't minimize the surface area. This is wrong because was it like material for the base cost here different the different like cost. $5 per square meter for the base. The $18 per square meter for size. The for size we have totally different like material. You can use like different materials. So what's the main idea? Find cost function. The cost function is here. You can find cost function. What's that? The area base is 2W squared times what's it like cost here? $5 per square meter. Just 5 times area base plus what's like area of base, the size, area of size is 6WH. 6WH. What's like cost? The $18 per square meter. So we have times 18. So we have 5 times 2 is 10W squared plus 18 times 6 is right? Exactly 108WH. It's like step 4. What's like step 5? The step 5 is the express cost function as a function of one variable. We have two variables right now, the W and H. How can you find the relation of W and H? The relation of W and height H. How can you find relation? Here. The relation of W and H. So here. The relation of W and H is here. What's that? So we have this information. Volume is 10 cubic meters, right? You can use it. So the volume is same to what? The length 2W times H. We have 2W times H. So what's it like a volume? Volume is given 10 cubic centimeters. The 10 equals the 2W square H. I want to solve this equation for H. You can divide the both sides by 2W squared. The H equals 10 over 2W squared. 2 is crossed out. 5 over W squared. You plug this one into H. So what's it like a cost function? Here. The cost function is 10W squared plus 108. 108 W times 5 over W squared. So what's it like a cost function? Cost function has only one variable W, C of W, the 10W squared. So 1W is crossed out. 108 times 5 is 540. So we have 540 over W. What's it like domain? The domain W is here. W is like the width of rectangular storage container. The length is and the width is always a positive number. We have this one. W is positive number. 10W squared plus 540 over W is right. So this is like exactly CW. So what's like main problem? Minimize the cost. How can you minimize the cost? We can use closed interval method, first derivative test, second derivative test. The closed interval method is impossible. Domain is only open interval from 0 to infinity. So we cannot use closed interval method. I want to use the first derivative test, right? The take derivative like a critical number or something like that. So we can use like this. Here, this one, plug, we have it like this. I'm going to use first derivative test. So C prime of W, the 10W squared plus the 540 of W prime. So what's that? The 10W squared prime is keep 10 2W plus 540 of W prime is, we can use a quotient rule here. The 540 prime, first top on prime times bottom on, minus top on times W prime over W squared. 540 prime is 0, 0 times W is 0. The W prime is 1, 1 times 540 is negative 540 over W squared. We have negative 540 over W squared. You can keep going. 20W over 1 minus 540 over W squared. So I'm going to find common denominator. The common denominator is 1 and W squared. Common denominator 1 and W squared is W squared. Only change the first one. W squared, like this. So we have the 20W cubed minus 540 over W squared. I'm going to factor out 20. W cubed negative, what's that? 27. So we have it over W squared. You can find critical number, like a critical number. What's that? The C prime of W equal to 0 or C prime of W does not exist. C prime of W equal to 0, exactly numerator equal to 0, W cubed minus 27 equal to 0. You add 27, W cubed equals 27. Take a cube root, W equals only 3. The C prime of W does not exist, bottom one equal to 0. W squared equal to 0, the W is 0. So we have W equals 3. We have one number like this. W equal to 0 is not in the domain. Domain is positive number, so you don't need it. So next, I can check. The W equal to 3 has like minimum or not, the minimum cost or not. I can draw domain from 0 to infinity. You can choose 3. You just only check. C prime of W is a positive or negative. I can choose test number 1. You plug into here. Plug 1 into here. 1 cube minus 27 is negative 26, negative. The 1 squared is positive. Negative positive is negative. I'm going to choose 4. 4 into here. The 4 cube is 64. Minus 27 is a positive number. The positive is positive. What's C of W? The C of W is decreasing and increasing. So what happens? Graph is decreasing and increasing. We have local minimum at 3. In this case, local minimum is exactly same to absolute minimum. Absolute minimum. So we have the absolute minimum at W equal to 3. The next, what's the like equation? The equation is here. Find the cost of the material of a cheapest such container. So what's that? So far, we have W here. You plug into cost function CW. The final answer is C over 3. 10 times 3 square plus 540 over 3. 10 times 9 is 90 plus The 3 is crossed out exactly. Right? The next one. 180. We have 270. Or the cheapest container, the $270. It's like the cheapest one, the cheapest one. So this is like the whole idea for solving this whole kind of problems. Okay, this is all for today's lecture. So if you have any trouble, any question, you just only write your question on the discussion board or send the email to me or Kasha that we can help you. So thank you for watching my lecture video. I hope that this lecture video is helpful for preparing your week 7 lectures and next week, like midterm exam 2. Okay, thank you.